Back, everyone. We are to chapter 9, and chapter 9 is all about sequences and series. And we'll go through and define each of these. We're going to start with sequences. A sequence is a function whose domain is the natural numbers 1, 2, 3, 4, 5, and so on. And sometimes we start at 0, depending on the sequence. And so let's go ahead and do our sequence here. So our sequence is 7n plus 3. And here we can see n is 1. So this is going to be 7 times 1 plus 3, which is 10. Here, n is 2. 7 times 2 plus 3, which gives us 14 plus 3, which is 17. And lastly, n is 3 now. So 7 times 3 plus 3 is 24. So just follow your order of operations. Next up, we have factorials. We use an exclamation point for factorial. Please don't call it an exclamation point. It's a factorial when we're talking in math. It's basically take whatever the number here is, times the number previous to it, times the number previous to it, all the way down to 1. And actually 0 factorial we're defining as 1 as well. So let's take a 5 factorial becomes 5 times 4 times 3 times 2 times 1, which becomes 5 times 4 times 3 times 2 times 1, 120. Now, there is a factorial button. On this calculator, it's here. I hit math, go to there, and there we are with the factorial. Every calculator has it at a different place as well. So you'll have to learn yours. B, we have 3 factorial. 3 times 2 times 1. Now, I want to point out, do you see we have 3 factorial buried in the 5 factorial? Right? So we have 6. We'll come back to that, actually. We're going to align that up right now, actually. So for A, 1 factorial divided by 1. 1 factorial is just 1. B is 2 factorial divided by 2. This just becomes 2 times 1 over 2, which also reduces to 1. C, 3 factorial over 3. 3 times 2 times 1 divided by 3. You can see the 3's reduce. We're left with 2 times 1, which is just 2. D, 4 factorial over 4. That's 4 times 3 times 2 times 1 divided by 4. You can see the 4's reduce. We're left with 3 times 2 times 1. Do you see that's 3 factorial, actually? The last one, I'm obviously not going to write out all of these terms. 25 factorial over 23 factorial. Now, 25 factorial is 25 times 24 times 23 times 22 times 21 times dot, 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 times 3 times 2 times 1 over 23 factorial, which is 23 times 22 times 21 times dot, 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 times 3 times 2 times 1. And can you see? Those are the same, and they reduce out, giving us the 25 times 24, which is 600. Factorials. And factorials are actually very, very useful in things like probability and counting. All right. Example 4. So we're given sort of a formula, and they want us to write out the terms. So let's start with A, first 4 terms. So we have when n equals 1, we have negative 1 to the 1 times 1 over 1 plus 1. This is negative 1/2. n equals 2. We get negative 1 to the second power, 1 over, I'm sorry, 2 over 2 plus 1. Now, negative 1 squared is positive, so that gives us positive 2/3. N equals 3, negative 1 to the third, 3 over 3 plus 1. Negative 1 to the third is negative 1 again. This gives us negative 3/4, and n equals 4, negative 1 to the fourth, 4 over 4 plus 1. An even exponent's going to make that even again, so we end up with positive 4 over 5. Now, part B is a little bit different. They give us the terms. So negative 1/2, and let's see if we can see the pattern. First of all, it's what we call alternating. It's negative, then it's positive, then it's negative, then it's positive, and so on. Just like this first one was negative, then positive, negative, positive. And the part that did that was the negative 1 to the n. And you can see we are back to where we started. So we can actually come up with an expression. This is our a sub n. And you can see these are our values. So we should be able to go both ways. All right. Next page, part 2. We are to series. Now, series just means take a sequence and add up the terms. And we're using a new symbol called sigma. It's a capital Greek letter S. It stands for sum, meaning add stuff up. And it's sometimes called sigma notation. Sometimes it's called summation notation. That really depends on your teacher's preference. And so sigma goes from k equals 1 to 4. And here's what that means. It means we're going to plug in for that, whatever the expression is in terms of k, is going to become a 1. Work it out, and there's my first sequence term. Then k is going to go up to a 2, then to a 3, then to a 4, all the way up until it hits the top number, in this case 4. So find the sum. So we're going to start with 7 times 1 plus 2 plus 7 times 2 plus 2 plus 7 times 3 plus 2. And this is when we're looking at k. K equals 1, k equals 2, k equals 3, and it says to stop at 3. So now we need to get all these together. So 7 times 1 is 7, plus 2 is 9, 14, 15, 16, 21, 22, 23. So 9 plus 16 plus 23. So we're looking at 48. Then we're going to go the other way and rewrite this term, or this in terms of sigma. We can use k again. Looks like k is going from 1, 2, 3, up to 9. So k is going to start at 1. We're going to go up to 9. And it's looking to me like we have a 3 in the bottom every time. And then the k that's changing, the 1, the 2, the 3, the 4, or up to the 9. So there we are. If you want to, some teachers put parentheses around that just to make it clear that it's the whole thing. All right. Number 7. So here we have what's called a recursive sequence, meaning I need the first term and then I have some mechanism to get the next term after that. So we're going to write up the first 5 terms. A sub 1 starts at 3. A sub 2 is going to be 2 parentheses. A sub 1, right, it's 1 less. So that's 3 minus 1, which is 2 times 2, which is 4. A sub 3 is going to be 2 times a sub 2, which is 4, minus 1. That's 2 times 3, which is 6. A sub 4 is going to be 2 times a sub 3, which is 6 minus 1, is 10. A sub 5 is 2 times a sub 4, which is 10, minus 1, which is 18. You may need to rewind the video and watch that again. It's a little tricky. All right, moving on. Part 3, properties. So let's just kind of walk through this. If we have a constant times our sequence, we can factor that constant out, so we can pull it out in front. That in higher mathematics becomes very, very useful. When we're adding or subtracting two terms, we can break them up into their own separate additions. And if we're adding up just a constant, it's summation of a constant, then it's going to be however many terms there are, n times that constant. You can see there's going to be a total here. If I'm going from 1 to n, there's going to be a total of n of these. So n times your c. If I'm adding up 1 plus 2 plus 3 plus 4 all the way up to n, this is our formula here. These generate what are called triangle numbers. If you ever get a chance to look that up, it's kind of cool. If I'm adding up the sum of squares, 1 squared plus 2 squared plus 3 squared and so on, here's the formula. Cubes, 1 cubed plus 2 cubed plus 3 cubed and so on. We get this formula here. We'll come back to these. Part 4. Practice with sequences and series. Write down the first 4 terms of each sequence. And we only have one that we're going to do here. So we have A. Now, when n is 1, it's going to be 1 over 10. And again, this is when n equals 1. Next up, it's going to be 2 over 2 plus 9, which is 11. So again, this is n equals 2. Next up, 3 over 3 plus 9, which is 12. And then equals 4. We get 4 over 4 plus 9, which is 13. All right. Now for example 9, we need to come up with our summation notation. And I want to notice in the denominators of these, I can view that first one as 1 over 6 to the 0 power, because anything to 0 power is just 1. So it's looking to me like the a sub nth term is going to be 1 over 6 to the n minus 1 power. So when n equals 1, we get 6 to the 0, which is 1. So 1 over 1 is 1. When n equals 2, let's write that out. A sub 1, we get 1 over 6 to the 0 power, which is 1. A sub 2, 1 over 6 to the first power. Remember, it's 1 less, is what I'm surmising. A sub 3 equals 1 over 6 to the second power, 1 over 36. And you can see that's exactly this pattern. So here is our nth term. These take practice. There's no shortcut for those, unfortunately. All right, so here we have a recursive formula again, and we're going to write the first 4 terms. So a sub 1 is equal to 2. A sub 2 is going to be the previous answer. That's the numerator. That is going to be 2 over 2 squared. So this 2, once again, comes from here. This 2 is coming from the subscript. So this is 2 over 4, which is 1/2. A sub 3 is going to be the previous answer, which is 1/2. over 3 squared. Okay, over 9 times 1 over 18. Okay, so 4 is going to be the previous answer, 1 over 18, over 4 squared. So 1 over 18 times 16. Don't know what that is off the top of my head. 18 times 16. So 1 over 288. So there are the first 4 terms. There, 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 and there. All right, we are back to here. Using these, and you can see this first one's a constant. It's 3 in this case. So when this n is 20, so this is going to be 3 times 20. The constant 3 times n, which is what we go up to, which is 20, so 60. This one, this is going to take a lot more work. So I'm going to break this up using these rules. These rules here, where I can pull the constants out and break them up and all that. And this becomes 4 times the summation k equals 1 to 12 of k squared plus the summation k equals 1 to 12 of k. And I have summation of k squared, so I'm going to be using these formulas here. So this is 4 times n, which is 12 times 13 times 2 times 12, 24, 25. All divided by 6. Plus, and now I'm going to use, so I just used this formula where I replaced all the n's with a 12. And now I'm going to go plus, and now I'm up here. I'm going to use this one here, where n is 12 in this case. 12 over 2 times 12 plus 1, which is 13. Whew. That is messy. Let's see what we get with that. So I have 4 times, let's go here, I guess. 4 times 12 times 13 times 25 equals divided by 6. Okay, 2600. Plus, I can see 12 divided by 2 is 6. So 6 times 13, 78. Chooses 2678. No problem. And for this last one, I'm going to break it up as well. K equals 1 to 15. K to the third plus summation. K equals 1 to 15. 3. Just recall, K to the third is this formula here. So I'm going to replace all the n's with a 15 now. And recall, with a constant, it's just n times c, so it'd be 3 times 15. All right, so here we go. This becomes n is 15 over 2 times 15 plus 1, which is 16 squared, plus 3 times 15. 16 divided by 2 is 8. 8 times 15. 8 times. Here, let's just do this. Let's do 15 times 16 divided by 2 squared. Ooh. Plus 45. This gives us 14,445. So you'll have to really take your time when using these formulas here. Make sure that you're doing the right one and all that. All right, and I hope that that was helpful.